IT Pro TV, binge-worthy learning for IT teams. Why is it binge-worthy? It's learning presented in an engaging and entertaining talk show format that beats voice-over PowerPoint snooze fests. Watch over 3,300 hours of content in their on-demand library on your desktop, on the go, or in the comfort of your own living room. IT Pro TV is IT training you and your team actually want to watch, which means a better return on your learning investment. Get started with IT Pro TV for Teams by visiting itpro.tv/Security Weekly and start a 7-day free trial and get 30% off standard or premium IT Pro TV memberships using the code SECWeekly30. The greatest threat to businesses today isn't the outsider trying to get in. It's the people you trust, the ones who already have the keys, your employees, your contractors, and privileged users. 60% of online attacks are carried out by insiders. To stop these insider threats, you need to see what users are doing before an incident occurs. Observe-It combats insider threats by detecting risk activity, investigating in minutes, effectively responding, and stopping data lost. Give it a test drive at observeit.com/Security Weekly. Are you overwhelmed by the sheer volume and noise of alerts? Struggling to define priority while searching for context? Wondering why we're still playing telephone while attackers invest in technology to ease their efforts? It's time to make a stand and demand a different approach. Imagine spending your day doing the valuable work you crave. It's possible today with ServiceNow. Visit servicenow.com/SOAR, that's SOAR, to get more information and make the case for your better approach to security orchestration and automation. Welcome back, everyone, to Enterprise Security Weekly. Just a quick announcement reminding people about itpro.tv. And as we talk about domain exploitation and you want to understand Windows domain environments, IT Pro TV has some great training modules on there. So whether you've worked with Active Directory in the past or you're coming up in the field in security, you're going to have to understand at least the basic fundamental concepts of Active Directory. To get that, you can find affordable training at itpro.tv and even subscribe to a team solution where your entire team can gain access to over 3,300 hours of training, including, like I said, stuff that really every security professional needs to know, at least a basic understanding of Active Directory. So check them out at itpro.tv/Security Weekly. Eyal Neemany from our sponsor Javelin Networks is here today to talk about hacking the Olympics, which I think is pretty cool. This was, like I said earlier, this was a big news article a couple of weeks ago when the Olympics were happening. Of course, that's now been kind of displaced by news of the largest distributed denial of service attack. Maybe the next segment could be on that, but certainly this was in the news, and Eyal is here today to give us a little more information. Javelin Networks didn't actually execute the attack, but you have information about the attack, which is awesome. I wanted to make sure we cleared that up before we start today's segment. Eyal, welcome to the program today.
Hi, thank you, Sam.
So what do you got for us today, Eyal?
So today I'll be showing you how the campaign of hacking the Olympics really operated. We'll actually go through the entire attack phases and also execute the malware in a contained environment.
Awesome. Take it away.
All right, so I'll share the screen in a moment.
Yay, it worked.
All right. So the background story, if you haven't heard about it yet. So December 5th, 2017, Russia has been banned from the Winter Olympics. As a result of the Russian doping allegations, Russia was suspended from the 2018 Winter Olympics. And from now on, the Russian athletes will be invited to compete, but just as a member of the OAR, the Olympic athletes from Russia. So they will not represent Russia. Their anthem won't play, their flag won't fly, and any medals they will win will not count toward the overall Russian medal count. So as the plot continues, at February 9th, technical problems were detected in the infrastructure of the Winter Olympics. The organizers are investigating whether the opening ceremony was the target of a cyber attack after a severe technological problems during the event. So reporters at the Pyeongchang Olympic Stadium noticed that the internet Wi-Fi stopped working shortly before the ceremony. Also, while the televisions and the Wi-Fi at the main press center also stopped. The organizers were also forced to shut the website of the Olympics, so users weren't able to print their tickets for the event. They only managed to sort out these technical problems after 12 hours later. And also, as the plot continues, at February 24th, this is a lot after the attack, the Washington Post mentioned that according to US intelligence agencies, the Russians also hacked routers in South Korea prior to the attack. This might be an initial infection vector of the new malware that they used. They also tried to make it appear that the intrusion was sourced from North Korea. So they were like trying to manipulate the geographic IP location of the attack and the whole attack phase.
That part just makes so much sense. Like, if the Russians are going to hack the Olympics, like, why wouldn't you want to blame North Korea for the attacks, right?
Yeah, they got a lot of reason to do that. Mm-hmm. So this is a new thing that probably most of you haven't heard about it yet. So creating backdoors in routers, just like mentioned in the article of the Washington Post. So just a few more facts about speculations about leveraging routers for hacking purposes. So definitely this one is not the first infection vector that comes up during investigation. So whenever you're investigating ongoing campaign inside your network, this is like the last thing that you'll think about, that someone managed to hijack your routers and hack into your routers, and from there you managed to get inside your network. It's usually much more easier and much more simpler, like social engineering or sending an email to one of your employees. So this is like one of the reasons that you don't hear about it that much. Basically, this method is exclusive to governments and spying agencies. It's very hard to operate and develop, but highly effective. The actual infection is usually done by using an exploit to create a backdoor or replace the firmware with an infected one. So if you manage to control the routers, you can actually control the entire region it manages. And also, like the one most important thing about hijacking a router, infecting a router usually won't alert anyone. It's like a blind spot of most of the network. Like, no one is going to look at it or try to monitor it for any suspicious activity, and there's basically almost no security solutions for routers whatsoever. So infecting a router opens new opportunities for your campaign, such as you can sniff and control the traffic of your infected network. You can replace or redirect the traffic to forward victims to download the malware and deploy it. You can also repack executables and replace it with a malicious one. So let's say that inside a victim environment, someone tried to download the file. So you're already inside the router and you're fetching this specific HTTP request, for example. And instead of returning the actual executable that you was trying to download, as an attacker, you will replace it and repack it with your malware, and eventually, the one that downloaded the file, it probably thinks it's legit, and it will execute it just like if it wasn't a malicious one. So this is like a very effective and hidden method to start your campaign. And of course, it's almost exclusive to governments and spying agencies.
Really, you think that largely those are the people who are executing those style? I mean, I started theorizing on those style attacks, about 10 years ago when I wrote a book on embedded routers. I was like, wow, you could do some really nasty things if you were to take over someone's router. Very much the same things that you were saying, Eyal. But you think today that we're largely seeing those attacks from basically nation-state attacks?
Yeah, definitely. Most of the normal simple attacks, the opportunistic attack, they won't do that. I mean, it's just take too much of a research to do, because you got to know what type of routers your adversary is using, what firmware is using in all of these routers. You actually got to have like a stash of modified firmwares that you can infect your adversary with. So
Yeah,
you'll be
and
able
then
to actually achieve the whole thing. So
and then you have to cross compile your binaries for that platform, which is like I just want to like stab my eyeballs with a fork every time I do cross compiling like that. I actually did it for the book. It was horrible. Very rewarding once you get it working, but it's just a terrible process.
yeah. Okay, so the Talos investigation. So like a few days after the actual attack, Talos uncovers that the samples were used in these attacks, um, along with a detailed report about all the malware functionality. And the main goal of the malware was actually to destroy all the endpoints and network share that they managed to spread into. First of all, they thought about they thought that maybe someone is trying to exfiltrate data from the Olympics network, but at the end they found out that it was only meant to destroy the entire network and disrupt the opening ceremony. So what Talos also reveals that the malware is dynamically changing. And as it reinfects other stations, it collects and changing itself with stolen information about the network and the credential that it collected so far with each infection. So they also believe that the attackers were already inside the network because the malware was already loaded with information about the domain, usernames, server names, and password of the Winter Olympics network. So this information just strengthens the possibility that the attackers might have infected the routers prior to the attack, just like mentioned by United States agencies. According to the investigation, no critical assets were infected, but the risk could have been huge. All right, so the malware kill chain and operation. So almost the same as all Windows malwares out there. Once the first computer got infected, we're seeing the same techniques being used again and again. So reviewing the malware actions step by step, you'll be able to understand that this is simple. This is like plain and simple, the same thing. Although the first initial infection vector is different, but we're seeing it again and again. So first of all, the main dropper executable is executed and drops additional embedded binaries and execute all of them simultaneously. So basically what the malware does, it just like copies all the data from inside it, from the initial binary, from the main binary into the temporary folder. So you have like 5 more additional executables being extracted from the like main executable. One part of the malware start to destroy your machine. This is like happens immediately. Once you just click launch, then everything is start to self-destroy itself. So what it does is actually deletes all the shadow copies of your Windows. So what it actually means is shadow copy is a Windows feature of backing up all of your volumes and files. The second thing that it does, it disables all the file recovery and boot options, so you won't be able to boot into recovery after the destruction. Another thing that it does is deletes all the Windows event logs. So if you want to like trace back what the source of the attack, it's making it impossible. So this is like an anti-forensics technique. Another thing that it does, disables all the Windows services. So we're just making sure, like again and again, that you won't be able to recover your PC. So disabling the Windows services, just making sure that once you boot up the Windows, nothing works. So that's like the main goal of it. This is like the actual destructive part. And the last thing that it does is wiping all your network shares, writable files. So it's scanning like the mapped drives inside your Windows, mapped shares, and just trying to access all of them and trying to delete every possible file that it can. So this is like one part of the malware, the destructive part. Another part of the malware is the Active Directory recon, a network recon. So it managed to do it with 2 options. So first of all, it's trying to fetch the ARP table, which is like getting all the IP addresses of the currently connected inside your LAN endpoints inside your network. So it gets like a bunch of IP addresses to reinfect. And the second thing that it does as a recon method is querying the Active Directory using WMI LDAP query, trying to just query the entire Active Directory for all the domain computers. So he has like a list of IP addresses, and he has a list of domain computer names. Another part of the malware is the credential theft. So as like almost malware out there, it's just like doing the same thing, but with one unique twist. So it tries to steal all the browser's credentials inside your computer. So if you have like a saved password inside your Firefox, your Chrome, or Internet Explorer browser, it will just try to steal it and then use it again to infect our endpoints. The second method, of course, is trying to steal credentials from the else's process using mimikatz and eventually try to pass the hash with the stolen credentials. And the last part is using the already stolen credential from the former infections. This is like the part that we call it the dynamically changing malware. And it's just like trying to reuse them again against other endpoints that maybe right now it does have a connection into. So we have like three methods of stealing credentials in this particular malware. After doing all this stuff, the next thing that we'll try to do is just like normal lateral movement. So we will use WMI to check if there is an active connection to a computer. And then eventually you'll try to execute psexec, just like almost every malware out there. So after trying to reinfect other computers, the next thing they'll do is just shut down the current computer after completing the entire operation. And from now on, you won't be able to boot up your PC again. So it just like crawls inside your network, just like a normal worm, and reinfecting the entire network until you finish to destroy everything. So that's like the main goal of the malware.
So in order of operations, Eyal, does it? I'm assuming it does the productive stuff before it does the destructive stuff. Otherwise, it's destroying the host. That it's cutting off. It's not cutting off the branch it's standing on. In other words.
Yeah. So actually, what surprises me here is that it's doing everything simultaneously. So like all of the parts that it's doing right now, like you can see the actual commands that the malware uses. So first of all, it's like making sure that the first phase is like making sure that nothing will boot up in the next reboot. So it's like deleting the shadow copies, deleting the catalog, deleting all the boot options to recover your PC. But the last thing that he does, just like you mentioned, is disabling all the services. So this is like the last part. So exactly, he's not cutting off his branch. So again, this is how it looks like, the actual running of the malware. So as you can see, the root process actually extracts another additional process. It's called the PUA. It's actually a random string. And what it does is just using legitimate tools inside your operation system. He's using VSS admin and WBA admin. This is just like executable that every endpoint has inside Windows operation system, but it uses them in a malicious way. So I mean, there's no way that you can distinguish between malicious activity and legitimate activity when using these tools. This is a very smart technique that most of the attackers uses nowadays. There's no way that any AV will be able to identify whether this is a malicious activity or not. So this is the main goal. And also in the bottom part of the slide, you can see that there is hard-coded credentials and usernames and domain names inside the malware. So definitely you can see that there was some recon behind the attack and before the actual initial attack. So someone studied the network, and then just after just studying the network and rebuilding itself, he sends the malware again to really attack the network. All right, so I'll be showing you guys a demo of the actual execution of the malware. This is like the actual sample that was used in the Olympic network, and I will be running it on a mimicked domain environment. So it is going to be with the same domain names and the same domain usernames as they used in the Pyeongchang 2018 Winter Olympics. And I'll also use it with Javelin So you'll be able to see how the malware operates and how it can be detected. All right. Okay, so in this demonstration, I'll show you the actual malware sample that was used in the Olympic network. And right now, the network is deployed with Javelin. And as you can see, there's no active attacks right now. So we'll execute the malware right now. It's the compromised system. So I'm running the initial dropper as a local administrator. This is crucial, so the malware will be able to dump the LSAS process. So once the malware is executed, it drops the additional executables and immediately start to perform reconnaissance, Active Directory recon and network reconnaissance. And as you can see here, the malware accesses one of the masked objects in the domain. So immediately there's an alarm. And it will also able to fetch the malicious process. And just as mentioned before, you can see that the malware contains an actual ransomware and destroyer code, PSXZ code, and also it was trying to fetch data from the Active Directory using reconnaissance. And at this point, also the malware is trying to perform pass the hash attack. So as I mentioned before, it was stole the credentials that was stored in the LSAS process, and it fails to do so and triggers an additional alarm. So he's trying to use the IIS admin user in order to infect other computers. So because of the malware failure to hijack privileged credentials, it wasn't able to perform lateral movement towards the domain network, and it only managed to destroy the local machine itself. Was also be able. You can also prevent this the local destruction if you would add another automatic mitigation feature, or you can just use any other automatic kill of the malware after the initial the attack if it's detected. So
Eyal, did Javelin's product detect access of the IS admin account, because that was like a fake account created by your artificial intelligence engine?
Exactly. So I just show you how the malware operates. So by using Javelin, I will be able to show you just that it does hijack all the malwares. The malware hijacks the credentials inside the memory, and was also trying to perform reconnaissance. That was the main goal of it.
Really cool.
Okay, so going back to the slide, just reviewing the entire thing again. So mitigation, so how we could have stopped this attack after the initial infection. So because the malware actually leverages multiple methods, one security product might not be enough in this time. Attackers are getting sophisticated nowadays, so bypassing almost every AV and next-gen AVs. So let's review each part of the malware again, malware code, and suggest how it can be stopped, using just normal creative rules inside your probably what you have inside your organization, your security product inside your organization. So the first phase is the malware is dropping additional files. So it is dropping additional files to the temporary directory. This is almost every malware out there does that. So it exports itself and does the melting technique into the temporary folder. So if you have a next-gen AV solution or a host IPS, you can create a rule of denying any attempt to write a file to the temporary folder if the source of the file that's trying to copy the file isn't signed. So this is probably will stop 50% of the attacks out there. Most of the malware automatically copies itself to the temporary folder. This is a cool technique that you might want to use inside your environment to prevent any automatic worms and ransomwares. The next phase is the Active Directory recon. So in this case, there's not too much to do. You might want to review solutions like masking the Active Directory and using deception to mask the AD, just like as you've seen in the video above, or maybe deploying any anti-scanning solution to your AD topology. The next part is the credential theft. So some next-gen AVs offers the ability to deny access to the LSAS process by unauthorized source. So this might work. But also if you have like Windows 10 credentials guard, you might want to enable that if you have the appropriate hardware to do that. But again, almost all of them can be bypassed if done by sophisticated attackers. So we're really seeing a lot of open source projects out there and new techniques that used each day by attackers and by researchers to bypass anything that all the security products is trying to defend on. So this is like the one crown jewel that every researcher is trying to bypass, the anti-LSAS accessing to perform credential theft. So eventually they won't be effective. So you might want to consider also deception to mask your domain credentials, or just use like all the other deception AD masking out there if there are. Another thing is the lateral movement. So in this case, I mean, the lateral movement is performed using WMI and PSExec. These are legitimate tools in most of the environment, probably being used by your IT department. So they won't be revealed often. It's really hard to distinguish between legitimate and malicious activity when using these tools. So maybe you just want to consider limiting the amount of privileged user inside your environment, so you will be able to limit the exposure once you are infected. Another like cool solution that you might want to do is create like a micro segmentation of your network, so it won't be easily accessible by anyone breaching your network from every spot. So it will be like limited for a small VLAN that it will be able to access to. So not your entire network will be infected, just like a tiny spot of it. And the actual payload is the machine destroy payload. So also in this one, the attacker used the integrated tools inside your operation system to do that. So the actual destruction was done by legitimate tools. There is no actual way to identify this behavior. But maybe if you'll try to create smart signatures inside your next-gen AV, EDR, or just using Yara rules, then maybe you'll be able to catch some of these while they're running. Also, in the next slide, I will show you an example of a possible behavior-based Yara rule that can identify the samples of the malware by the parameter it uses in these commands. So here we go. If you want to check this out, so it's also shared in our GitHub and easily accessible with the QR code. You can use our Yara rule to detect the malware running in memory. So basically, what you're seeing here is when you're looking at the actual like tools that the malware used, it's not malicious. I mean, if you'll see it during your investigation, you won't be able to identify if it's malicious or not. So, but if done with just like the right parameters, this can be like a very good and just very precise indicator that the executable that you're viewing, the process that you're analyzing, might be involved in an attack. So almost all of the parameters above are related to recent campaigns. Maybe you've heard about the NotPetya or all the other spreading worms out there of the ransomware worms and all the other wipers. So all of them almost using the same methods. So we like assembled like a very quick and good and precise rule to catch all of them. And also the malware uses anti-forensic technique. So maybe if you'll try to catch the anti-forensics code, you'll be able to catch the malware as well, instead of just like going back and forth and trying to look for the log. So Maybe
Yeah,
like
our other sponsor, actually, Minerva Labs, does just that. That's kind of their claim to fame.
yeah. So it makes sense. It makes sense clearly. Um, so trying to find the actual attempt to perform the anti-forensics or anti-AV techniques will also be able to you'll be able to identify like a very good indicator of malicious activity. And that's it.
Sweet.
That's like
That's
if you want,
awesome.
you can download the YARL from our GitHub, also available using the QR code.
That's awesome. Yeah, and thank you for that, contribution in the community. I know a lot of us are using YAR rules. I'm told it's kind of like a cat and mouse game, with YAR rules, I think. There are some people that have expressed some frustration with them, but it can be a very valid technique. I think in specific cases like this, it might be good to, have that in your arsenal. So,
Yes, also, I'm a big fan of YAR rules, so I like creating YAR rules. Also check out, I know about what you're talking about. I mean, the cat and mouse game with hunting malwares and trying to fetch all the correct strings using your YAR rules inside your environment. So that's definitely something that everyone in the security industry should look for. It's very easy to use. I mean, it just makes sense. You can scan your entire networks with YAR rules if you're using it with like appropriate tools. It's very effective, very fast, and very precise. And you're also like getting the entire database and intelligence of the entire world when you're using YAR rules. So there's like pretty much like a huge database of YAR rules open in GitHub for everyone to take. So everyone, if you just gotta use Yara. I mean, that's the way to go.
No, that's good, and actually something I need to include in my upcoming presentation on using open source tools for enterprise security. That's good. I had kind of not slated to include that, but now certainly I'm going to highlight the rule that you've given out for free, which I think is really awesome. Based in this segment. So, Eyal, thank you so much for appearing on Enterprise Security Weekly. Thanks to our sponsors, Javelin Networks. You can find out more at javelin-networks.com. And thank you, everyone, for listening and watching. See you next time.